Hello and welcome to my presentation about protocol buffers. Let's start with a swift introduction. Okay, what will we talk about today? I will first explain what is protocol buffers, then I will show you the format definitions, and then I will talk about advantages of protocol buffers compared to other options. So, what is protocol buffers? First, protocol buffers is a mechanism for serializing structured data. It's something like XML or JSON, but it's binary and therefore smaller, faster, and simpler. It's easy format definition and all else is generated automatically. Protocol buffers is language neutral and platform neutral. That means that it doesn't depend on any single language or platform. You can use it anywhere you want. Only limitation is the number of languages for which you can generate the code, but all main languages are supported. Okay, so now the format explanation. I'll tell you about data objects, how the code is generated, and how you can serialize your objects. And in the end, I'll tell you a little bit about RPC. Okay, so in order to serialize anything, you must first describe it using special protocol buffers format. This means creating a file with file name extension .proto. In this file, you can define multiple message types. As you can see on the screen, message is a unit of serialization and usually has several data fields. Here we have 3. Each data field can be either required, that means it has to be set in the when you use the generated code, it has to be set exactly once, or it can be optional, that means it can be set at most once, or repeated, that means it can be set any number of times, once, twice, or thousands of times. And it must have specified type. As you can see here, we have string and 2 integers, 32-bit integers. All basic scalar values types are available, including integer, float, double string, and boolean, and their variants. As you can see on the right side of the screen, there's all the variants you can imagine. So all the basic types are available. And also you can see individual variants of the type in several languages like C++, Java, Python, and Go. And when the code is generated, these specific types in the languages are used for getters and setters. So moving on, enumerations. You can also use enumerations, and that means that you can specify several values for the type that can be used. And now, more interestingly, more complicated data types. If you want to use something more complicated than just the basic scalar types, then you can define a message, like here, define the message result, and then use this message result as a type in another message, like for example here, search response. You can use it in several other types. So basically the options are quite unlimited, or as limited as in normal languages. And here is when you have an optional type, you can define default value. So for example here we have optional 32-bit integer, and its default value is 10. That means that if we don't set it, we cannot set it because it's optional, and if we don't, then value 10 is used. If we do, then what we set is used. Okay, let's move to services and RPC. If you want to use RPC system in protocol buffers, you can define an RPC service interface using previously defined messages. That's search request and search response here. Protocol buffers compiler will then generate service interface code and stubs in your language. Now let's see the example. It's in C++. We have client and server code here. Let's start with the server. On the server side, you implement the service. For us, it's example search service. It's just a simple implementation of Google search. So if we look at the query, if it's Google, then we return Google URL. If it's protocol buffers, then we return protocol buffers URL. That's all we do. Now, on the bottom of the right side of the server sides, we can see the definition of the service where we define which implementation of the service will be used, and then we set on which part will it run. And we just started by writing server run. It's all on the server side. On the client side, we make the search, which we first have to define where is the server. So there is some URL and part defined in the new MyRPC channel. Then we use the stub created by protocol buffers, and we point it to the URL and part. Then we set the message that's used as the request message. So we use the request set query and we set it to protocol buffers, and then as last step we execute the RPC itself. And in the response variable we will have the response returned. As you can see on the right side, it will be either Google URL or protocol buffers URL. And that's just easy example how to use RPC. Now, some advantages of protocol buffers. First advantage is its performance. Because it's binary, it's much faster than XML, JSON. It's also quite simple to use. Maybe not on the first, maybe not in the first second, but after a while, when you get into it, it's actually quite easy. Little disadvantage is that you can't display the raw data and understand it because it's binary. It's just some strings may be readable, but other things are just gibberish. And compared to XML or JSON, where you can see all the information when you open the file. But this approach is much faster, and in the long run, I think it's worth it. But it depends on what you are doing, actually, as always. You don't have to worry about the serialization. That's a big advantage, because if you are sending some data over network, for example, then when you have a string in C++ on one side and you want to get a string in Java on the other side, there can be differences in how it's interpreted on both ends. So there can be a lot of problems with that, and protocol buffers solves this. And another advantage is that it doesn't matter what languages are on both sides. So it can be Java and C++, Python, Go, anything you want. It always works just fine, and no matter what platform, if it's Linux, Windows, Mac OS, or anything else that you can run protocol buffers on, of course. And now to the typical use cases. There are basically two. It's always when you communicate between where two programs communicate. So it can be communication over network, so it's client server, something like that, but not necessarily a client server scheme. And the other basic thing how to use it is storing objects into file. You have some data in for example C++, and you want to store it in a file so that you can stop the program and start it up again later or something like that. And this will give you a fast method that can serialize the data quickly. It's you can use multiple languages, so it doesn't have to be that C++ creates and reads the data. It can be that C++ creates the data, writes it to a file, and some other language like Python will read the data. And it's binary, so it's also quite compressed, and it doesn't use too much space.
So next thing is a little example. So let's get right into it. So here's a premised example. We have 5 files here. What they do is simple thing. We have address book, which can store information about some people. We have 2 files that can interact with this file. One is @person, which can create a new person and add it to the file. Other one is list people, which just prints all created people so far. We have Java and Python version. The versions are compatible, so that means we can create people in one and read them from the other language. They both use the same file, the same definition of the types that are defined in the addressbook.proto file, so it works just fine, no problems with that. We could actually use even more languages like C++, Go, Dart, anything, but for the show you how it works, I think 2 languages are just enough. Okay, so let's look at the addressbook.proto file. It's pretty straightforward. At the beginning, we can see that we are saying that we are using protocol buffer syntax, version 3 syntax. We named the package tutorial. We imported some Google Protobuf timestamp definitions, which is used here in the message. And the most important thing is this person message, which defines what a person is actually. So we have several fields. We have a person has a name, ID, email, several phone numbers, which are defined in an inner message phone number. So phone number is basically a string, and a phone type, which is actually again defined with a bit higher as an enumeration of 3 possible values. And then we have timestamp. And then another message we have here is address book, which just is a repeated sequence of several people. That's pretty much easy. So now let's describe the Python code. Let's start with list people. So basically what happens here is we take one command line argument with the file name. We create one instance of address book class, which is the class, the Python code describing the class was generated for us using the .proto file. Then we read the file, and we call generated function on the address book, which is parsed from string, which will just take the data in the file and create the address book instances from it. So all the people we created so far. And we call the list people function. And here, a little bit higher, what happens is we just print the information. So for every person in the address book, we print his ID, name, email, phones, and so on. So that's pretty straightforward. And now let's look at the other file, which is @person. Here it's really similar. We also get the file name from command line as a command line argument. We create the empty instance. We again parse the data, we asked the user to put in data for a new person. So we create a new person here. Actually, we create the instance, and here we have the empty instance, and we ask for the information. It's like ID, name, email, and so on. And we set it to the person. So you see here we have the person here as the argument, and we set person ID, person name, person email, all those things. And here, after we return from the function, then we created empty person here. Now it's filled with information, and we again open the same file, and we serialize the data from the others book into the file. So that's the complete Python version. So now let's look at the Java code. Let's start with the list people file. We have main function here because we are not in Python but in Java here. But we again do the same things. We read the file name. We create we parse the others book from the contents of the file, and we print the information, which is again we go through all the people and print the ID, name, and everything. So that's pretty straightforward. And now the add person Java. Here we have again main function. We get the file name. We create a builder. We build the address book from the data in the file. And we call a function on address book class which is called add people, and we add what is returned by the prompt for address function, which is defined higher. And let's look at it, what it actually does. It prompts for address, so it's asks user to put in the information like the ID, name, and so on, and it sets it to the person here, and which is a builder for person. So we are using generated code. And when we get all the information here, then at the end we build it and return it. And we are back at the bottom when we got the returned and built person, and we just simply add it in the address book. And now all we have to do is put it back on the disk, and that's again done via address book build and write to output. So here's the hidden serialization, and that's basically all that is done here. It's just again, it's just 5 files: 2 Java, 2 Python, 1 Proto, and this is all the things we have to write manually. So what we are going to do now is generate some code, and to do so we need Protos compiler. It's used via this command, but now we don't have it installed, so we can't use it. Because we are running Ubuntu, we can actually easily install it using a package manager. The package is called Protobuf compiler. So when I run it, it just installs, and now when I run the Protos again, see I have the help information is displayed, so it's installed. You can even look at what's the version. I think it's like this. Nope. It's like this, the version of the compiler. But what we're gonna do is compile the proto file. We must say for what language we are generating the code. So first it's gonna be Python. You can actually see it in the help information a little bit higher. So it's Python out, and their directory where you want to generate the code. So you generate it right here, and another argument is the proto file used as the source. When I run it, it goes without any errors, and we can see we have a new file here, address book protocol buffers 2, which is generated file. We could look into it, but it's not important what's inside, because it's just generated code, nothing interesting. And now basically all we need to do is run any of the Python source files. So now let's try and run the code. So it's Python @person, and now let's pick a name for the data file. This it's been created because it hasn't existed yet. Let's put some data in. So 0 ID, name. Let's not put any email and telephone number. Let's create another one. So it's ID1, name, Peter, blank email, and phone number. Let's keep again. And now we can run the other file, which is list people. Like this. When you run it, we actually see the output, the ID, name, and the names. So now let's look at the Java. We have to do three things with Java. We also have to generate the code from the .proto file, but because it's Java, we have to compile it, and we actually have to download one library. So let's start with downloading the library. I already have the URL in history, but you can find it on Protocol Buffer's web pages. So I just downloaded it. As you can see, we have it here. Now let's generate the code, which is again similar to the Python. We just like this. It's pretty much the same. So we've generated the code. It's here in the com directory. And now let's compile our code. I have it also in history, so let's look at it. There's class path set to the jar file. There is the two classes we are compiling, and the generated code. So I ran the compiler. It works successfully, and we can see that we have two new files. It's @person class and list people class. So now when we have all compiled, generated, and downloaded, we can actually run the Java. And again, I have it in history because I wouldn't remember it, and it's like this. And it's again the class path